Hi everyone. I wanted to make a program to help me seat the students in my classes. A couple years ago in my calculus class, I had 36 students and they were sitting in groups of 4, and I wanted to know what was the maximum number of different seating charts I could make where no students sat in the same group. Sorry, no student sat with another student more than once in the same group. And it turns out that's a really hard combinatorial problem to solve. That particular case, a solution exists already, but that area of problems is known as combinatorial block design and seems pretty hard. So this year, actually, I'm interested in just coming up with pairs. So for the AP Computer Science students, for example, I want to come up with a bunch of seating charts where I just pair the students in working pairs. And I actually don't care where in the room they're sitting, I just care who's working with whom. But I want it to be the case that everybody works with everybody as a partner, and nobody's going to repeat a partnership. So that's the goal of this program, and I'm going to live code it. First, let's do a little bit of planning work. So it's not necessarily obvious ahead of time that it's possible to create as many charts as I want. So my friend Danny and I came up with the following. It might have been Aaron, actually. But Danny and Aaron came up with the following way of constructing seatings. So this is an example where there are 6 students. We'll go ahead and assume that there's an even number of students, because if there was an odd number, we couldn't pair them up anyway. So we're going to take one of the students and we're going to put them in the middle. And then we're going to, actually here, let me make a bunch of these. All right, so in this seating chart, I'm pairing this student with that student. In this seating chart, I'm pairing this student with this student. In this seating chart, I'm pairing this student with that student. I'm pairing this student with that student, I'm pairing this student with this student. So you can sort of think about this as like the central arm of a clock as it's rotating around. Now, how am I going to pair the other students? I'm going to pair them sort of symmetrically across that first pairing, like this. Okay, so if we look at this, there were 6 students, and this has given me 5 different seating charts with pairings. And I think you can see that with n students, this is going to give me n minus 1 seating charts. It's also pretty clear that that's the largest number of charts available, because if you think about the constraint on my seating, if I'm a student and I have like a list of all the students who I've sat with so far that I keep track of during the year as I'm sitting in more and more seating charts, I'll just check students off one by one. So as soon as I've checked off, so if there's 36 students in the class, if I've checked off 35 other students, that's as many students as I could possibly sit with before I'm forced to sit with another person. So in general, if there are n students, there's going to be a maximum of n minus 1 possible seatings for everybody. And this way of constructing them gives you all n minus 1. So what I'm thinking is, maybe we'll pass the constructor a list of student objects whose indices go from 0 to n. I'll choose the nth student to be the student who's always in the middle. And what's nice about this is this gives me a unique identifying number for each of the possible seating charts, because I just have to ask which index is student n paired with. Here, n is paired with student, let's call this student 0. Here, n is paired with student 1. Here, n is paired with student 2, and so on. So each of these seating charts now can be identified with a unique number that will let you generate that chart given a list of students. So I think that's what I'm going to try and implement right now. All right, here we go. So I've got my seating pair generator class. I'm going to go ahead and make a runner class. That'll be like my main one. I'm going to make a seating chart class. Maybe I shouldn't call it seating chart. Well, The reason I don't like seating chart is because it's not necessarily a chart, but I'll come up with a better name in a minute. I'm going to make a student class, and I think I'm going to make a student pair class, or maybe a working pair class. Oops. All right, right now my student is just going to have a name, and that's it. Working pair is going to be a pair of students. I'm thinking, should I have 2 fields or should I have an array list? I think maybe I'll have an array list. Well, yeah, I'll have an array list. Okay. For the seating chart class, I'm going to make a static list of students that will be the class list. And I think I'm going to make it final as well. Well, yeah, we'll come back to that. I'm not totally sure a clean way of initializing this when I mark it final, so I'm not going to do that right now. So now for each individual seating chart, I'm going to have a list of working pairs, and that will be the actual chart. I'm going to make a private constructor, which is going to take a list of working pairs as input. And now I'm going to make a factory for creating these. So public static seating chart, generate chart. And then I'm going to give it a unique integer n, and that's going to correspond with the seating chart that I'm generating. Perhaps I should add some comments. So given n students, this will return a unique seating chart pairing corresponding to n, with n is going to be between 0 and n minus 1. So actually for my seating chart, I think I should also probably have it have an ID number that's going to be the n. All right. So let's see. First, I'll put in some checks. So if class list is null, or class list.size equals 0, system. So I'm going to print out, need to set the class list first. I guess I should probably make a method that will let me do that. And I'll return null if class list dot size mod 2. So this is testing to see if there's an odd number of students. Then So I'm going to tell it there must be an even number of students to run the generator. And again, we'll return null. Cool. So I'm going to okay, so now I've got to actually write the algorithm that will generate the list. So I'm going to write a helper method for that. So list working pair pairs equals generate pairs with an integer n. And then I'm going to say return new seating chart pairs and n. And that'll be my factory method. Okay, so let's make generate pairs. So I guess first I'm going to construct pair with center student at index at last index. Okay. So student last student equals class list get class list dot. All right, let's do this. Equals class list dot size minus 1 is the last index. Okay, so there's my last student. So working pair, initial working pair is going to be new working pair, and then I'm going to get, right, so for the seating chart n, I'm assigning the last student to work with student at index n. So let's add a precondition here. N must be between 0 and class list dot size minus 2. N represents student to pair last student with. Therefore, n must be there. Okay, great. All right, so that's going to be last student and class list get n. So I guess maybe I'll enforce my precondition. If n is less than 0 or n is greater than class list size minus 2, okay. Go ahead and make my constructor. What? That's weird. Oh. All right, so I'm going to add S1 great. All right, so I've generated that initial working pair. So now let me go back and look at my diagram. So what I want to do, so let's look at the one that I have circled. So I've constructed this working pair. Now what I want to do is I want a loop where I is going to be 1 and it's going to go up to a certain number, and I want to pair n minus I with n plus I, but it's gotta sort of wrap around this circle. So I'm gonna make, so for int offset equals 1, offset is going to be less than or equal to, what should that be? So there's n minus 1 people around the circle, and that's an odd number. So n minus 2 divided by 2, I think is what it should be. So class list dot size minus 2 over 2. Okay. Great. And then offset plus plus. Okay, so now what I'm going to do is I'm going to say student 1 index equals n plus my offset, and student 2 index and minus my offset. Okay, so wrap index is going to be my helper method that's going to wrap the indices in the right way. So what I'm going to do is I'm going to say so I equals I mod, or let's do this, while I is less than 0. I guess there's not a possibility it could be a lot less than 0. So if I is less than 0, then I'll say I equals I plus class list dot size minus 1. Does that make sense? Here, let's look at the picture. So, for example, here I'm at 0. When my offset is 1, I'll be at 1, and this will be negative 1. But I really want negative 1 to correspond to this index, which is 0, 1, 2, 3, 4. Classlist.size is 5, so classlist.size minus 1 is 4, and that is what I want it to be. No, that's not what I want it to be. This is n minus 2. Or so this is classlist.size minus 2, because this is because the center student is classlist.size minus 1. Great. Okay, so classlist.size minus 2. Oh no, but I want to add classlist.size minus 1. Does that make sense? Because if I'm at negative 1 and I want to get to 4, then I do need to add 5. And 5 is classlist.size minus 1, because it's the length of this outer circle. Okay. Cool. Great, and now I'm going to say I equals I mod classlist.size. I think here I want minus 2, but let's just think about this again. So if we're at, right, so if we're at classlist.size minus 1, which would be 5, I want that to wrap around to 0. No, so this should also be minus 1. Because it should be the total number of students in the outer circle. Great. All right, cool. So we want this to be in the range 0 is less than or equal to I is less than or equal to classlist.size minus 2. Okay. So where were we? All right, so I'm wrapping the indices in both directions. So now I want to say, oh, let's go ahead and make my list of working pairs that I'm going to be returning here. So all right, so now that I've constructed that one, I can say pairs.add init. Now I can say pairs.add new working pair classlist.get student1 index and classlist.get student2 index. Great. And I believe that should do it. And now I'll return the pairs. All right, fair enough. So student and then working pair okay. So I've made my two strings so that I can see the complete seating chart. And so now seating chart, I'm going to make it have a two string. Which is going to be just pairs.toString. That might not look the best, actually. So, well, this is going to be a little bit dirty. So for working pair, pairs, so p.toString plus \n. Okay, so now return out. Okay, not the most beautiful and not the most efficient either, but that's okay. We don't need efficiency here. All right, so I've got my seating chart. It's getting constructed with the ID and the pairs. That makes sense. I've made the thing that will generate the pairs. Cool. So I think I'm ready to do some. Oh, I don't have a way of setting the class list. So let's do that. And then let's generate some test data and then let's do it. Set class list is going to be static. And I'm going to let us do it with a string array. And now I'm going to say what did I call it? Class list. Okay, so if class list equals null, then I'm going to say class list equals new array list student. Else, I'm going to say class list dot clear. And now I'm looping through it. And now I'm saying class list dot add new student. That's getting constructed with a name. All right. Oh, that's the timer. I gotta go grab something. Okay, I'm back. Oh yeah. So I was setting the class list, right? So we create a new array list, or we clear it, and then we loop over the names, and we make new students to add to lists. Great. Let's make another one. Set class list. Only this time, it's going to be with. Let's just have it be a list of student objects. Like this. Oh, right. Okay, and so now actually instead of class list, well, I guess that's okay. I was going to have this one call that one. I think that's probably fine. And let's do one more. Well, no, maybe that'll be fine. Okay, so runner. Okay, so I'm going to call my students, or let's do this, A, B, C, D, E, F. Okay, so string names equals students dot split on comma space. So that should give me the names. So now I'm going to say seating chart dot set class list names. So now I'm going to generate a bunch of charts. So generate chart corresponding to I. Now let's print. I'm going to just print a divider. And then I'll print seating chart C. All right, let the debugging begin. Yeah, all right. Oh, what? How did that even happen? Oh, okay, yes, let the debugging begin indeed. Cool. Invalid index. Okay, so somehow I've set the indices wrong. So invalid index happens where? If it's greater than class list.size -2. Because, no, -1. Because if their n is 6, so if there's 6 students, we can get seating charts, so we can get 5 seating charts, but that's going to be 0 through 4. Oh, so it is -2. Okay. Okay, so maybe here in the runner then, so we do have 6 students. Oh, so this is running 6 times, so it can really only get 5 seating charts. Okay, there you go. Okay. F with A, B, C, D, E. So now B, so okay, so let's do it this way. So F is with everybody. Let's check to see if E is with everybody. So E is with B, D, A. Is E with B twice? E with B? No. E with C, and E with F, okay. And now let's check D. So D is with C, E, B, F, A. Okay, cool. This seems like it's working. All right, so this is great. So I'd say my next steps are write something so that I can read in my student names from a text file and generate the charts, and maybe print them out. Another nice thing would be if I could, so this is really only like the model. This is like who's sitting with who, but it might be nice to make a nice view for it so that it would actually display the student pairs where they were actually sitting in a room given a seating layout. But I will do that at a different time.